Hi, my name is Rachel. I'm a curriculum developer and animator at Explore Learning, but today we're going to see what happens when we put flowers in water with food coloring. So first, you'll need some containers to put your water and flowers in. I have these little glass containers, but you can use anything. You can use regular cups. And you'll need some water. I put this water in the microwave for about a minute to warm it up a little bit to help us dissolve our food coloring. So the first thing I'll do is fill these cups with a little bit of water. Then we're going to put different amounts of food coloring in each of the containers. So I have blue food coloring, and in the first container I'm going to put 1 drop. It's a big drop. I'm going to mix it up to dissolve the food coloring. And this container I'm just going to leave with plain water, no food coloring. So now what we're going to do is put flowers in each of the containers. I've got these 2 different kinds of white flowers, and I'm going to put 2 in each container. So what you want to do is you want to cut the end of the stem on an angle, like this. That way we can get some of the surface exposed, and then set the flower inside the container. So I'm going to do that for each of the containers. Okay, and now we'll wait and check it in the next hour, and maybe the next day, and in a few days from now, and see what happens. Okay, let's take a look at the flowers that we're in our dye water. So this is the blue water with the least amount of blue dye. I'll take out the flower. You can see blue on the tips of all the petals. If I turn it around to the back, you could see the blue dye that went up some of the petals. Here's the flower that was in the blue dye with a little more blue food coloring. Looks like there's a little bit more. Here's the blue flowers in the water with the most blue food coloring. Look at that, lots of the tips are blue. And you can see where the dye traveled all the way up the petals. Here's a flower that was in the green dye. You could see the green. Here's one that was in the red dye. You can see the red. Here's one that was in yellow. See a little bit of yellow, but it's kind of hard to see. And here's the celery stalk where the bottom has been in the blue dye. And you can see that there's blue all the way up here at the top of the blue celery leaves. So the blue dye traveled up from the bottom of the celery stalk through its xylem up to the leaves. Let's see if we break it. You can see where that blue dye is. You see that? The spindly part of the vegetable that's usually kind of tough to eat. That's where all the blue dye is. Let's take a look at a gizmo that will help us understand what was happening in the flowers and celery. So we're going to use the gizmo called Sticky Molecules. So you'll want to go to the Explore Learning website and type in Sticky Molecules and select it. Then click here to launch the gizmo. And you'll want to select the Capillary Rise tool and drag it to the tool area here. And select one of the liquids. I'll start with water and drag it here. And this is a capillary action experiment. Capillary action is what happens when liquid is able to flow in small spaces. So here we're using water with a thin capillary tube. And if you add water to the Petri dish by dragging the dropper over and letting it go, you'll see that water will rise in the capillary tube. So that's essentially the same thing that's happening in the flower and the celery. The water gets pulled up the stem of the flower through the petals or the celery stalk, and that happens because of the intermolecular forces in the water. And so the cohesion between the water molecules, as well as the adhesive forces between the water and the capillary tube, help to pull that water up the small space. And so that happens with any liquid and any small tube. And different liquids will behave differently. So water has strong cohesive forces, which means it can be pulled up the capillary tube pretty high. Whereas if you take a liquid like hexane instead, which has weaker intermolecular forces, then it'll be pulled up less. And you can try different liquids and see what happens. Then you can compare the intermolecular forces between the molecules by determining how far the liquid is able to rise in the capillary tube.